Here we go. So today's lesson is something called Cramer's rule, named after a guy. Not this Cramer. You may recognize him from Seinfeld. Anyone ever heard of Seinfeld? I hope. Maybe. Anyways, it's not this guy. It is this dude, this older mathematician guy named Cramer. I don't know what his first name is. But anyways, this is going to be a new way for you to solve a system of equations. So exciting. So in order to solve for this system of equations, we're going to use something called a determinant, which again, I'll show you how to calculate. It's very simple. And this system of equations, remember from watching that Edpuzzle lesson, you'll recall that we've got this elimination method or the substitution method that you should have reviewed. And we're looking for an ordered pair. Like that's our end goal, is to get this x and y value that when we plug it into all the equations in the system, every equation ends up being true, right? Like the left side will equal the right side, but it's true for all of the equations in the system. Typically, we only work with two. And substitution, elimination, you might have your favorite between those two already. But this is a new one that you haven't seen back in Algebra 1. And it's a little daunting at first, but once you try it a couple times, you'll see how easy it is and how simple it is to get your x and your y. And so I'm going to go through that today. And another big benefit to this is if you're ever using like fractions or decimals, which are a pain in the butt with like substitution or elimination when you're trying to cancel something out, this works a lot better for you because it's a pretty easy calculation to do this determinant. Let's get started. So first off, what is a determinant? This is a new term for you. And a determinant is a special calculation that you use for a grouping of numbers. And the setup is kind of weird because the determinant has these vertical bars, which looks like absolute value. You know, it's the same kind of a thing, these vertical bars, but it's not around one number. It's around four different numbers. And I've just generically labeled them A, B, C, and D. They could be any four numbers, positive, negatives, they could be zeros, they could be one digit, they could be a 200-digit number, whatever. And once you've got the numbers set up in this like 2x2 grid, then you're going to calculate the determinant by this simple equation. You take A times D, which is basically this first diagonal, right? A times D, and you multiply those numbers together. And then you're going to subtract, make sure you use subtraction, that opposite diagonal. So C times B, or B times C, you'll get the same answer, right? Multiplication, the order doesn't matter. And so you multiply those two sets of numbers, you subtract them, and whatever you get, you're going to get a single number, and that single number represents your determinant. So for this new Cramer's rule, we're going to calculate three different determinants, and we're going to get three numbers, and just by combining those numbers, we're going to get the solution to the system of equations. We'll get that x value and that y value. So let's practice it really quickly with this example for calculating this determinant. So just like in my little note there on the left side, we start by taking the first diagonal. Now I always remember the first diagonal because it's in the upper left corner. Like I always start up here in the upper left. Just like if I were reading a book or a website, you always start in the upper left-hand corner. And so you always start there and you multiply those two numbers together. Well, in this case, 4 times 5 is just 20. And then we're going to subtract. Make sure you put in that subtraction sign before you even bother looking at the next set of numbers, because you must include that subtraction. And then I take this other diagonal and I multiply it. So negative 6 times 8 gives us negative 48. And now we just have to subtract these two numbers. Now remember, whenever you're subtracting a negative, that's the same thing as adding a positive number. So really this is 20 plus 48, which again, you can all do this without a calculator, and get 68. And that's it. That's how you calculate a determinant. You just multiply two sets of numbers and subtract them. Done. So for this new method, you just have to do that 3 times. You need 3 determinants, which I think you're all more than capable of, right? I know all your cameras are turned off, but just like give me a nod or a thumbs up as if I could see you, and I'll assume you are, and we'll move on, okay? So is everyone good with this?
Yeah.
Yes! Thank you so much, Tiana. I appreciate that feedback. So now gets to the crazy part. How do we set up these determinants based on two equations? First, the equations need to be written in the correct form. And you should recall this from Algebra 1, but we're going to use this form called standard form. And standards form is pretty simple. All it means is that the x's and the y's all have to be on the left side of the equal sign, and then the numbers without variables are going to be on the right side. So if it's not set up this way, just make sure you rearrange the terms so that x and y are on the left. Make sure that x is first and the y is second. And then it equals the constant, the number that doesn't have a variable with it. And do that for both equations. Again, make sure x's are first, y's are second, equals, and then those constants. All right, so that's standard form. Make sure both equations are set up that way. Now we're going to set up three different determinants, as I mentioned earlier. I'm going to represent these with a d sub x, and a d sub y. When I say sub, it means like a subscript where it's kind of written down a little bit and to the right. And so the first type of determinant we call is the coefficient determinant. All right, so this word coefficient, you've probably heard me use it a few times. If you're not sure what that is, I've included the definition down here at the bottom. That's just the number in front of a variable. So if I've got a term like 3x, well, the 3 is the coefficient because it is the number in front of the variable. D sub x is what we call the x determinant. So we're going to use this to find the x coordinate of our solution. Remember, we're looking for an ordered pair for this system of equations, an x and a y value. And d sub y is simply the y determinant. We're going to use this value to calculate the y coordinate of that ordered pair in our final solution. Another term that you should be familiar with that I actually used on the previous slide is a constant. So you've got the x variable, the y variable, and then there's this term that's just a number without a variable, and that's called a constant because it's constantly that number. It doesn't vary. It doesn't change. Hopefully these two terms at the bottom you already remember from previous math classes. You shouldn't need to write those down, but make sure you've got these three up here, d, dx, and dy, the coefficient determinant, the x determinant, and then the y determinant. All right. So just going back here, these numbers in front of the variables are coefficients. Now, hey, this x doesn't have a number in front of it. If that ever happens, remember that there's always an invisible 1 in front. And so -1 would be the coefficient of the x because there's a negative sign. If there weren't a sign, you'd just use a positive 1. So those are coefficients. There are 4 of them. These numbers, the 18 and the -10, those are constants because they don't have a variable next to them. That 18 is always 18. -10 is always going to be that 10. And so they're called constants. So we need to make sure we've got that terminology down pat. All right, so you've got these different determinant notations set up. Now let's look at how I set up each of these three different determinants before we can go ahead and just do that quick multiplication to calculate each one of these. So I'm using that same system of equations that we had earlier. So you probably have this already written down in your notes, hopefully. And I'm going to show you how we set up each of these three. All right. And we're going to go ahead and we can calculate them pretty quickly too. So first, set up D. That's the coefficient determinant. So let's take a look at it. I've got a 2, -5, a -1, and a 3. And if I look at my original equations, well, check it out. That 2 is right there. Then I've got a -5. This x has a -1. And then that second y has a 3, which is right there. And so that's my coefficient determinant. It's just those 4 numbers written in that order. And I even wrote this note down here. That's the coefficients of the variables. So, you know what? Let's go ahead and calculate this real quick. because it should be pretty easy for us. Let me just go up to the board. So to calculate this, remember you take the first diagonal, which is 2 times 3. So that's going to be a 6. And I'm going to subtract the product of the opposite diagonal, which is -1 times -5, which gives us a positive 5. Now, when I subtract these two numbers, well, 6 minus 5 is a 1. So guess what? That is D. It's got a value of 1, which is nice and easy. So that's the first determinant. Again, that calculation should have been pretty simple for you. And that's your first value. And we're going to be using this 1 in our final solution to find the x and the y of the system of equations. All right, so that's the first determinant. Now let's look at the second one, dx. So you're going to notice a few things about this. So this new determinant looks a little different. And what we did is we started with our original coefficient determinant. All right, so if I look back at this one on the left, that was made from all the coefficients. This new one in the middle here, it looks similar. And hopefully you'll recognize that the right column, like the -5 and the 3, that's the same as our coefficient determinant. And so the only change to this from the first one is this first column right here. Now, if you look back at our original coefficient determinant, that first column represented the x coefficients, the 2 and the -1, right? That came from these two terms in our original equation. And so to create the x determinant, we're going to replace the x coefficients with these two numbers, this 8 and -10. Well, where did these crazy numbers come from? Well, those were just the constants. If you look back at our original system of equations, that 18 and that -10, those were the numbers that were all by themselves on the right side. So to calculate this, we're taking, replacing the x coefficients with the constants that came from our original system of equations. You leave the y column alone. So we think of this as the y's, that's the -5 and the 3. Those coefficients still stay put. So those didn't change at all, right? The -5 and the 3. So that's the setup for the determinant for the x determinant. And now let's go ahead and calculate this also, really quickly. Let me get a little bit of room. So remember, you always take that first diagonal, which is 18 times 3 is, I believe it's 24. And no, 54. I'm sorry. I'm silly sometimes. 54, that was 18 times 3. And always put the minus sign right away because you're subtracting. And now look at that opposite diagonal. -10 times -5 is positive 50. And when we subtract these, nice and easy, 54 minus 50 is just a 4. So that's it. That's the dx we're going to use. So that number is a 4. Remember the first one, we had a 1 for the coefficient determinant. The x determinant is a 4. We only have one number left, and then we're going to have our answers nice and easy. So let's look at this last grouping. You may kind of have an idea already of what we're going to do. So for this last determinant, we are simply taking that original coefficient matrix again. And so remember, we had that first column were the x values, that second column was the y values. And now for dy, if we look at my little note at the bottom, you're just replacing the y coefficients with the constants. So look at this first column of x's, that's the 2 and the -1. We don't change those, right? If I look back at my original coefficient matrix, that column stays the same. What we're doing instead is I am replacing the y coefficients with 18 and -10 you'll recall that those are just the constants from our equation. So I'm plugging in an 18 and a negative 10 in place of the negative 5 and the 3 from the y coefficients. So for the y matrix, you replace the y coefficients with the constants. So let's go ahead and calculate this determinant. Just like before, we're going to take the first diagonal and multiply it together. So 2 times negative 10 is negative 20. We're going to subtract that opposite diagonal, the negative 1 times 18, which is negative 18. And make sure you keep those negative signs straight, because a lot of times students will multiply 1 times negative 18 and say, oh, that's subtraction. And they'll have only one minus sign in between the 20 and the 18. But remember, you're subtracting that number. And since you're subtracting a negative number, it's actually going to change into addition. So this is like negative 20 plus 18, which gives us a negative 2. And so that is dy, a negative 2. And so right now, I've got these three numbers. We have a 1, a 4, and a negative 2. Now, calculating them wasn't that difficult, like the actual math, right? We're multiplying and then adding or subtracting. Now, at this point, we're just going to use those three numbers to get our final solution. So remember, we've got a 1, a 4, and a negative 2. So here's all we have to do. To find the actual x and y values of our solution, remember, we're looking for an ordered pair to solve a system of equations. All we need to do to find the x coordinate is we've got this simple fraction. You take that x determinant and you divide it by the coefficient determinant. So our x determinant, if you remember back here, that dx was a positive 4. So I'm just going to write positive 4 divided by the coefficient determinant, that regular d. And again, look at that previous slide. D was just a positive 1. So my x coordinate, my final solution is just 4 divided by 1, which is just 4. That's awesome. So my final solution is going to be 4, comma, whatever my y coordinate is. Now, how do we get this y coordinate? It's pretty much the same thing. It's just my numerator is going to be the y determinant instead of the x determinant. So let's go back to that previous slide. And dy, my y determinant, was a negative 2. So I just take negative 2 and I divide it by the coefficient determinant, which was a 1, which remember, that's what we used for the x over here. So they both have the same denominator. It's that same coefficient determinant. And negative 2 divided by 1 is just a negative 2. And that's going to be our final answer now as that ordered pair. So 4, comma, negative 2. So that's it. That's the solution to the system of equations. If I plug that into those original two equations, they both would come out true. That's crazy, right? I know. That's all you have to do. 4 divided by 1 and negative 2 divided by 1, piece of cake. Now I know these determinants, setting them up is the only crazy part. And that's going to take you a little bit of practice. Because if you set them all up right away, like this can look pretty daunting. There's tons of numbers. It looks like a bingo sheet or something like that. And that's why I suggest calculating d, dx, and dy first. Get those actual three numbers, and then just divide them out so that your screen doesn't necessarily look like this chaos. So let's try one more together, all right? So go ahead and write these two equations down, and we're going to use Cramer's rule to solve them. So 2x plus 3y equals negative 2, and 8x plus 6y equals 10. Okay, so you've got those written down. Let's try solving them with Cramer's rule. So first off, make sure they're in standard form, which they are. Right? I've got the x's and the y's on the left side, and the constants are on the right side. Now we need three numbers essentially. These three determinants. I need d, I'm going to need d sub x, and I'm going to need d sub y. So we're going to figure out what these three determinants are. The first one, d by itself, that is just the coefficient determinant. And so I'm looking for the four coefficients, and you just write them in the same order that they show up in these equations. Just like that, like I've underlined them. So it's going to be a 2, a 3, a -8, and a 6. All right, so I'm just writing those four coefficients of the x's and the y's. When we calculate them, we take the first diagonal, 2 times 6, which is 12, and we subtract the second diagonal, -8 times 3, which is -24. We're then going to calculate this. Well, subtracting a negative is the same as adding a positive. So 12 plus 24 is 36. And that's our first number. Remember, we just need three numbers, then we can make those two fractions really easily. So let's set up the second determinant, dx. Now, this second determinant, the x determinant, it's going to look just like the coefficient one with one difference. I'm going to replace the x coefficients, so I'm going to replace the 2 and the -8 with the constants of a -2 and a +10. So x always goes first, so I'm going to put these constants first. The -2 and the 10 go on the left. The right side is still going to be the same as my first determinant. That coefficient determinant is the 3 and the 6, which we got from the y terms. Those are the y coefficients, 3 and 6. We don't change either of those numbers. So this is the setup. And we're going to go ahead and calculate this. So we take that first diagonal, -2 times 6, which gives me -12. And right away, put that minus sign after your first number. Make sure you put that minus sign so you remind yourself, hey, this is subtraction. Now look at the second diagonal. That's going to be a 10 times 3, which is 30. All right, so to calculate this number, we just take -12 minus 30, which is -42. Awesome. That's our second number. We only need one more now, and then we'll have our setup for that final solution. So we have one more determinant to calculate, and that's dy, or the y determinant. And to figure this out, again, go back to that original coefficient determinant, and this time I'm going to leave the x coefficients alone. So I'm going to leave the 2 and the -8, those coefficients that came from the x's in that original matrix, that first column. And I'm going to replace the y coefficients because this is the y determinant. So that's the one that we changed. And I replace them with the same constants of a 2 and a 10. Those are the only constants in our problem. The -2 up top and the 10 on the bottom. The exact same order that they're written in those original two equations. So now we just have to calculate this determinant, which I think we can do. I think we're getting pretty comfortable with this now, with this determinant process. We take the first diagonal, 2 times 10. That equals 20. Subtraction. Always put that minus sign right away so we don't mix up our negatives and positive signs. Now we take that second diagonal. -8 times a -2 would be a +16. So like that's another situation where make sure you've got that minus sign already in place for that subtraction operation. You're subtracting a positive 16, which looks just like this, 20 minus 16. And hopefully we can all do that without the calculator. That's a 4. And now we have all three of the numbers that we need for our ordered pair for that final solution. So I need my x coordinate and my y coordinate. So just to remind you, the x coordinate is the x determinant divided by the coefficient determinant. Now we've already got these numbers. We just figured them all out. dx is a negative 42. D is a 36. Those numbers just came from these three values right here that we just calculated. Those are the numbers that we're using in these fractions. Now that fraction can be simplified further. 42 and 36 are both divisible by 6. So this simplifies to negative 7 over 6. Gross, a fraction. But we didn't have to actually work with that fraction. That was easy to deal with. Now imagine if we use substitution and you get a negative 7/6 for an answer, then you've got to plug that fraction back into the other equation, and it's just going to be gross. It's a pain in the booty. So that's our x coordinate, and you can leave it just like a fraction. You're done. You don't have to do anything else with it. You don't have to divide it out or get a decimal or whatever. So now let's figure out the y coordinate. This is a very similar fraction, but I'm using dy over d. So the y determinant we calculated was a positive 4. And d, well, that's that coefficient determinant, again, is 36, which we used up here with the x's, the same denominator for both of these fractions. But I can simplify 4 over 36, because those are both divisible by 4. That leaves us with 1/9. Yuck, another fraction. But look, we don't have to do any calculations with that fraction. We just leave that as our final answer. So now I can put these both together to write my final ordered pair, x comma y. So the solution to this system of equations is negative 7/6, comma, positive 1/9. Box it up, and that's the solution. I know, crazy, right? It is crazy. Especially if you look at the screen right now, it's like it's blowing up all the way. So this is just a new method, a new technique for solving these systems of equations. And I implore you to try this one several times. Watch this video, look over those notes again. Once you get that setup of the d, dx, and dy, it should be a piece of cake. And because this fraction division is super simple. You've got some delta math to do to practice this and for homework. So give that a shot, finish that up before our next class, our next meeting together, whenever that is for you. And you've got this. This is good. Oh, wait, tomorrow. Wait, what hour? Oh, Friday. So yes, finish this up before Friday, or the delta math. Give it a shot, practice it, watch that help video in delta math, and you should be all set. So send me an email if you're still struggling with it, but really give it an honest effort. And I think you'll like this method a little bit more than substitution and elimination. All right. Hopefully you're all having a great day. I'll talk to you later. Bye.